Siglent Technologies SSA3021X Spectrum Analyzers Review, Honest RF Results and Proof Inviting. What if your spectrum analyzer was quietly lying to you, showing a clean signal while interference hides just below the noise floor? That is a real problem for RF engineers working on precision designs every single day. Weak sensitivity, poor phase noise, and missing resolution can turn a 2-hour troubleshooting session into an all-day ordeal. The Siglent Technologies SSA3021X spectrum analyzers were built to stop that frustration before it starts. If that sounds relevant to your bench work, keep watching. Picture this. You are mid-project, trying to verify a transmitter spectral mask or characterize a filter response, and your analyzer simply lacks the resolution to separate closely spaced signals. You adjust the RBW, try different sweep speeds, and still get a blurry, ambiguous result that leaves you guessing whether the signal's actually clean or just hidden in the noise. That quiet frustration compounds over hours. You end up second-guessing measurements, running redundant tests, and losing confidence in your data. For engineers doing EMI pre-compliance checks or antenna tuning, a noise floor that is too high means weak interference signals go completely undetected until they become expensive post-production failures. And here is the thing. Most budget spectrum analyzers make you choose between sensitivity and resolution. You get one or the other, but rarely both in a compact, field-ready instrument at a price that makes sense for smaller labs, startups, or university environments. Then everything changed when I started working with the Siglent Technologies SSA3021X spectrum analyzers. Do not just pick any spectrum analyzer. Make sure it has all digital IF technology combined with a free built-in tracking generator, so you never experience inaccurate signal measurements and expensive component workarounds again. That combination is rare at this instrument class and price level. Here is what makes it genuinely powerful in real use. The displayed average noise level hits minus 161 dBm per hertz, which means extremely weak signals become visible and measurable instead of disappearing into the floor. The minimum resolution bandwidth drops to 1 hertz, giving you the precision to separate narrowband signals that most analyzers smear together. Phase noise sits at minus 98 dBc per hertz at 10 kilohertz offset, critical for characterizing clean carriers and spotting close-in interference. The free tracking generator covers 100 kilohertz to 2.1 gigahertz, enabling filter sweeps, amplifier gain measurements, and antenna VSWR testing without purchasing extra equipment. Total amplitude accuracy stays under 0.7 dB for consistent, repeatable data. A university lab coordinator told me their students could complete a full filter characterization session in one afternoon using this instrument alone. Which capability matters most to you right now? The credibility behind the Siglent Technologies SSA3021X spectrum analyzers comes from people who actually use them under pressure. An RF engineering consultant described it as a staple lab instrument for verifying transmitter spectral masks, specifically praising the all-digital IF for eliminating temperature drift issues that plague older analog designs. A hardware reviewer called it the most bang-for-buck spectrum analyzer available and noted it replaced expensive legacy units in their workflow because of its speed and accuracy. An industry analyst confirmed that Siglent disrupted the mid-range test and measurement market by delivering minus 161 dBm sensitivity at a price point that previously required 3 times the investment. One ham radio developer shared that the tracking generator turned a previously tedious filter tuning process into a 5-minute task. I personally noticed how responsive the 10.1-inch display felt during fast sweeps, with no lag between parameter adjustments and on-screen updates. The Siglent Technologies SSA3021X spectrum analyzers deliver professional-grade RF analysis, from a minus 161 dBm noise floor to a free tracking generator in a compact instrument built for real bench and field work. Join thousands of RF engineers, researchers, and educators already relying on this analyzer for precise, repeatable measurements across telecom, EMI testing, and component characterization. Results may vary based on your application and setup. I have dropped my link in the description and pinned it. Just click and see for yourself. It might be exactly the upgrade your lab has been waiting for.
For demo videos and current pricing, check the link in the description.